Welcome to the DIY Honda Garage channel. The DTC P16E5 indicates a LIN, local interconnect network communication error related to the PCM, Powertrain Control Module, and DC-DC, direct current to direct current converter. This error may arise from intermittent electrical failures or disruptions in communication within the electrical system of the vehicle. The LIN communication network is crucial for enabling communication between various components of the vehicle's power management system, including the DC-DC converter, which steps down the high voltage from the hybrid battery to a usable voltage for the vehicle's electrical system. This troubleshooting guide will help diagnose the problem by checking various components and connections involved in this circuit, ensuring that they are functioning correctly and are free from any shorts or opens that could cause communication failures. The error P16E5 symbolizes a LIN communication problem, specifically between the Powertrain Control Module, or PCM, and the DC-DC converter located in the engine compartment of the Honda CRV. The PCM is responsible for managing the engine and transmission control systems, ensuring optimal performance and efficiency. The DC-DC converter steps down high voltage from the hybrid battery system to a lower voltage suitable for use by various electrical components. The communication path between these two components is pivotal to regulate power distribution and system diagnostics. When a communication failure occurs, it can disrupt electrical flow, leading to further complications with related components, therefore requiring careful inspection and resolution to maintain vehicle integrity. There are several potential causes for the DTC P16E5. Firstly, wiring issues are common culprits. These can include damaged or frayed wires that interrupt communication between the PCM and DC-DC converter. Secondly, poor connections, particularly at the DC-DC converter or PCM terminals, may hinder proper communication due to resistance or incomplete contact. Additionally, faulty components, either within the LIN system, like the DC-DC converter or PCM, or associated sensors, can trigger this DTC. Identifying the exact cause is essential to ensure accurate repairs and restore proper operation of the communication system. Symptoms of a P16E5 error may manifest in various ways. Commonly, warning lights may illuminate on the dashboard, alerting the driver to a potential issue within the vehicle's electrical system. Additionally, the vehicle may experience poor performance. This could include issues with starting or maintaining power, particularly under load. Electrical malfunctions can also result, leading to erratic behavior of systems reliant on stable power input, like the radio or climate controls. Being vigilant about these symptoms can enable early detection of the error, potentially preventing more extensive damage or repairs. In the first troubleshooting step, start by turning the vehicle to the on mode, ensuring all electrical systems are powered without starting the engine. Next, use the HDS, Honda Diagnostic System, to clear any DTCs, including the P16E5. After clearing, turn the vehicle to the off or lock mode and wait a moment before switching it back to on. This process allows the system to reset and establish a fresh state for diagnostics. Finally, check for any pending or confirmed DTCs using the HDS once more. If P16E5 appears again, further diagnostic steps will be necessary to explore the underlying cause. The second step involves checking for any other pending or confirmed DTCs using the HDS. Specifically, focus on DTC P16E2, which is another LIN communication error related to the ACG, alternating current generator. If this code is present, follow the protocol outlined for that specific DTC, moving to step 5 of its troubleshooting sequence. If P16E2 is not indicated, continue through the subsequent steps to pinpoint the cause of the P16E5 error. It is crucial to follow the established diagnostic path to efficiently identify where the breakdown in communication may be occurring. During the third troubleshooting stage, the technician must again check for any other pending or confirmed DTCs, specifically looking for P16E3, which indicates a LIN communication error linked to the battery sensor. If P16E3 is confirmed, follow the outlined steps relevant to that DTC. If not present, the diagnosis proceeds to the next check for additional codes. Understanding the interrelationship between these codes is essential, as anomalies linked to the battery sensor can affect multiple systems within the vehicle, including the DC-DC converter and PCM. In this step, continue to verify any pending or confirmed DTCs, particularly focusing now on P16E8, which involves communication errors related to the shutter grille system. If indicated, the technician will need to shift focus to following the diagnostics for this error. If P16E8 is not detected, the process allows the technician to move forward to the next diagnostic step. This systematic approach to narrowing down error codes ensures that all potential causes are evaluated, facilitating a thorough understanding of the problem. Now, to assess potential causes, turn the vehicle to off or lock mode and disconnect the DC-DC converter connector A, which has 3 pins. This step is crucial for checking the integrity of the communication circuit. With the connector unplugged, use a multimeter to measure the resistance between test point 1, the female terminal number 1 on the DC-DC connector A, and test point 2, which is the body ground. This test determines whether the resistance is above 1 megaohm, 1 MO. If the resistance is adequate, the analysis continues. If not, subsequent steps will focus on repairing any shorts or opens in the wiring. In this step, use the HDS to jump the SCS System Control Schematic line and wait for over 1 minute to ensure the diagnostic system is primed for accurate continuity testing. The next action is to check for continuity between the DC-DC converter connector A terminal number 1 and the body ground. This is done by systematically disconnecting each connector one at a time, including the alternator, PCM, 12-volt battery sensor, and both shutter grille connectors. If continuity is lost upon disconnecting any specific connector, it indicates that the LIN bat sensor LIN wire is intact, pointing to a failing component needing replacement. If continuity remains, it suggests a short in the LIN wiring that must be repaired. Reconnecting the DC-DC converter connector A is crucial before proceeding with this diagnostic check. Next, disconnect the alternator connector to isolate it from the circuit. Again, measure the resistance between the alternator connector A, terminal number 1, and the body ground to determine if it is 1 megaohm or higher. This step will help in evaluating if there is any significant resistance that may indicate a failure within the DC-DC converter or its circuitry. If the resistance is adequate, the investigation continues to the next step. If not, it may be indicative that the DC-DC converter needs replacement. Once more, use the HDS to jump the SCS line and wait over 1 minute, setting up for the resistance measurement. Disconnect the PCM connector A and DC-DC connector A, which allows for a clean measurement. Taking this precaution is vital, as it ensures no external influences are affecting the readings. Measure the resistance between test point 1 on the DC-DC connector and test point 2 on the PCM connector, looking for a reading of 1 ohm or less. This indicates that the LIN wiring integrity is solid. If the reading is satisfactory, the diagnostic process should look for authorized service data regarding any further DTCs or symptoms related. Otherwise, repairs are needed in the LIN wire. In this step, ensure the vehicle is in the off mode before disconnecting the DC-DC converter connector A. Ensure to measure the resistance between test point 1 on the connector and the body ground once more. The evaluation needs to confirm if there is 1 megaohm or more. If the resistance is adequate, it provides assurance that the LIN bat sensor, LIN line, is connecting correctly, guiding you to potentially look for other issues in the system. If resistance fails to meet this criterion, you must move forward with further tests for wiring integrity. Jump the SCS line using the HDS once again and wait over 1 minute to prime for continuity testing. This step repeats checking for continuity between the terminal number 1 of the DC-DC converter connector, A, and body ground, while systematically disconnecting critical connectors one at a time. It is essential to determine if any break in continuity results when disconnecting a particular connector, which indicates that particular circuit segment is intact while others may be compromised. If continuity holds, it requires repair of any shorts noted across the LIN wires to ensure proper communication amongst components. In this 11th step, reconnect the DC-DC converter connector A and disconnect the 12-volt battery sensor connector to investigate any potential wiring issues further. Measure the resistance between test points again to ensure the health of the connection line. This measurement is taken to check if the resistance is 1 megaohm or higher, which is critical for ensuring a solid circuit. If the resistance passes, it may require moving forward to further steps. Otherwise, consider the DC-DC converter to be the faulty component needing replacement. Following a similar pattern, jump the SCS line with the HDS and take care to ensure all connectors are disconnected for a proper electrical reading. Measuring resistance between the DC-DC converter connector A and the PCM connector A becomes crucial once again. The goal is to determine if the resistance is 1 ohm or lower. A good reading here indicates the LIN wiring is operating correctly. If problems persist, this could point to more intricate failures deeper in the circuitry, or identify component failures in the PCM that may necessitate a replacement. Reconnect the DC-DC converter connector A after verifying earlier checks. Then, proceed to disconnect the relevant connectors to measure the resistance accurately. Measure the resistance between the test points, keeping an eye on ensuring it reads 1 megaohm or more, signifying sound wiring integrity. This audit indicates whether the LIN bat sensor, LIN line, connects correctly, impacting any further analysis. If the test does not pass, the investigation should continue toward identifying shorts or breaks in the wire connections. Jump the SCS line using the HDS and hold off for 1 minute before proceeding with continuity checks. Disconnect connectors and proceed to methodically evaluate the continuity by removing one connector at a time, observing to see if continuity disappears when a connector is disconnected. This technique of testing helps to localize areas that may have issues in the LIN wiring system, where some wires effectively carry signals, while others may have failed. If testing indicates issues, repairs should be initiated along the identified pathways to restore complete function to the LIN communication system. Reconnect the DC-DC converter connector A before proceeding with this next diagnostic stage. The shutter grille connector must be disconnected next for accurate resistance testing to be performed again. Following these connections, measure the resistance between the shutter grille connector and the body ground. Testing here is crucial to adjust measurements, ensuring proper functioning of the LIN lines. Resistance of 1 megaohm or more indicates successful checks, while lower readings point toward potential malfunctions that may necessitate further repairs or component replacements. In the final troubleshooting phase, jump the SCS line again and take care to measure resistance after disconnecting critical connectors. This test will correlate the readings from the DC-DC converter to the PCM connectors, providing a clear understanding of whether the LIN wiring is functioning as intended. Look for a reading of 1.0 ohm or less, affirming that the connection remains intact. If all tests pass without issue, any further adjustments should focus on diagnosing component failures or other associated wiring issues impacting the communication circuit within the system. After performing all required repairs based on the previous steps, it is crucial to reconnect all connectors thoroughly to ensure that all systems are operational. Clear the DTCs once again using the HDS, as this will prepare the vehicle for a monitoring period. After clearing, it's essential to take the vehicle for a test drive to ensure that it operates smoothly without any warning lights reappearing. Monitoring performance during the drive will provide feedback on whether the issues have been addressed effectively. It additionally ensures all components communicate correctly, confirming repairs have resolved the initial DTC. To prevent future occurrences of DTC P16E5 or similar errors, regular maintenance is vital. This includes inspecting all connectors associated with the LIN communication circuit to ensure they are secure and free from corrosion. Additionally, monitoring wiring for signs of wear, fraying, or damage can help catch potential issues before they escalate. Ensuring that software updates are applied as they become available is also essential, as manufacturers often release updates to both software and firmware to address communication issues and bugs. Adopting a proactive approach will lead to improved vehicle reliability and performance. In conclusion, resolving DTC P16E5 involves a step-by-step diagnosis of the LIN communication error between the PCM and the DC-DC converter in the Honda CRV. Careful inspection and testing of the involved wiring and connectors are key to identifying the root causes of the error. By following a structured troubleshooting process, technicians can efficiently isolate the source of the issue, whether it be poor connections or faulty components. Finally, implementing preventive measures as part of regular maintenance can significantly enhance the on-road performance of the vehicle and its systems, thus avoiding reoccurrence of the DTC. Please like and subscribe to the channel. See you next time.